If you're like me while playing survival Minecraft, you'll put items into chests without ever organizing them. This can lead to what the Minecraft community calls a chest monster. It's messy and brings about unnecessary difficulty when finding your items. There is a chest tracker mod that you can use to highlight the item that you need to find, like so. Wait, this is perfect. There's literally no need for more elegant solution. If you play vanilla Minecraft, you might want to put signs on the chests to categorize each item and be able to easily find them later. And rotten flesh. Because who doesn't need a chest dedicated to rotten flesh? And then you put rotten flesh into here, ores into here, and any building blocks that you have go into here. Later, you can just look at the signs without having to individually open each chest and just go, oh, I need building blocks. Let me get some from here. Very convenient. However, this requires more work on your part because you need to manually organize your items into the marked chests. If only there was a way to automatically sort and categorize the items into the marked chests. Oh wait, we can. This is your standard item sorter. Hopper facing into comparator, into redstone wire, into redstone repeater, facing into redstone torch. That locks the hopper. If you have a container full of mixed items, and you want to take one specific item out of that container that is sorted out, it's very simple. All you have to do is fill all the slots of the hopper below with the item that you want to sort out. Now, the hopper can only take redstone out of it since all of its slots are filled with redstone and redstone can only stack with each other. But this limits you to 5 storage spaces or 5 stacks. And if you try to add a container beneath it, such as a chest, to expand the amount of spaces for that item, what happens is it ends up working until the container full of mixed items runs out of the item that you want to sort. In which case, the filter item that you had to prevent other items from getting into the hopper gets sucked into the container below as well, and it stops working. So we want this hopper to send items through, but stop sending items through once it reaches a particular amount, so that the redstone dust stays in and keeps acting as a filter. This is the circuit that does exactly that. Wait, but how does this all work? Well, in order to figure out how this works, we need to figure out what the comparator does. The comparator has many functions, but the one that we utilize in order to make sorting systems is that it can read how full a container is and output a signal strength based on that information. So, if we fill that hopper to the brim with the maximum amount of items it can hold, then it'll output signal strength 15. It will never go to 16 and light this redstone lamp because 15 is the maximum. If we fill this hopper with the minimum amount of items it can hold, it'll output signal strength 1. Basically, the more items we have, the more powerful the signal strength. So what this comparator does is output a signal strength of 1 normally, but once it reaches a signal strength of 2 as the contents of the hopper fill up more, it powers this redstone repeater, turns off this torch, allowing this hopper to unlock and pull items from the hopper above it. It's easier to understand if you look at how it's configured. 18 of the item that you want to sort in the first slot, and filter items in all 4 of the other slots. By the way, these filter items should be items that you would never input into the sorting system. Usually, you'd rename these for extra security, meaning that unless the items have the exact same name and are the exact same item type, they won't stack to these filter items. It just so happens that 18 plus 4 items is the maximum amount of items where the comparator will output a signal strength of 1. If the amount of items in the hopper goes even 1 over this amount, then the comparator will start outputting a signal strength of 2, like so, which will power this repeater and turn off this torch, which unlocks this hopper and allows it to take an item from the above hopper. And once it goes back to 18, the comparator will stop outputting a signal strength of 2 and go back to signal strength 1, which unpowers this repeater and turns the torch back on, locking it again. This means that we can pull items from the hopper into a bigger container such as a chest, but stop pulling once the amount of items reaches a particular amount so that we can keep filtering. This item sorter design may be 1 wide, but it is not tileable, meaning that you can't have duplicate slices next to each other without them interfering. This is important because when things are tileable, it allows you to have neat storage slices like this right next to each other. So this could be one item, and this could be another item. These slices are right next to each other and are easy to access, making it space efficient and compact. But why isn't this item sorter design tileable? Well, it's because it doesn't have something called overflow protection. Let me give you an example. Let's say that you had one slice dedicated to sorting redstone, and another slice dedicated to sorting diamonds. Well, if the amount of redstone in the first slot went to 64, one stack, either because you inputted items too fast and the sorter couldn't keep up, or this chest got full and the redstone started piling up. Well, what would happen is, the comparator not only goes to signal strength 2, but also goes to signal strength 3, powering this redstone line as well, which interferes with this slice, meaning that even though you would only want this slice to be activated and for this hopper to be unlocked, the adjacent slice gets activated as well, meaning that this torch turns off and diamonds start leaking through here, even though redstone is the item that's currently being sorted. There is a solution for this though. We can extend the length of the redstone wire in order to increase the signal strength that the comparator needs to output to turn off the torches. This variation is known as a signal strength 3 item sorter, while the previous one is known as signal strength 2. The overflow protection works like this. Even if the item in the first slot goes to 64, which is the maximum amount of items that one slice can have at any given time, it only goes to signal strength 3 and can only ever activate its own slice. It can never go to signal strength 4 and also activate this slice as well, meaning that it can't interfere with adjacent slices even if it's holding the maximum amount of items it can handle. This does come with the downside that you need more of an item in order to form a filter for it. Maybe we can have both the low filter item count of the signal strength 2 filters and the tileability of the signal strength 3 filters. Introducing the signal strength independent item filters. These are built in a way so that the redstone in one slice never interferes with the redstone in an adjacent slice. This means that we can use signal strength 2 item filters, as you can see by the 2 redstone lines, without the redstone ever interfering with each other because the redstone lines never touch. With signal strength independent filters, however, we need to tile them in an A-B configuration. If this slice was A and this slice was B, for example, then we would tile them like A, B, like so. Since we don't have to worry about redstone signals overflowing, this means that we can configure the hoppers like this, meaning that we only ever need one of an item to form a filter for it. Now that we've figured out our item filters, we need a way to transport the items over the item filters with the appropriate logic. We want the items to attempt to go into the item filter, but then move on to the next filter if it fails. This is already halfway achieved using our item filters, as they only take in items they are assigned and reject any other items. There are a couple of ways to go about achieving this, and one of them is using a hopper line. In a hopper line, items will always reliably go down before going sideways, due to how hopper logic works. This means that if a hopper tries to go down, but fails to do so because the item filter is set to only receive one item, then it will go to the next hopper and check for the next item filter. This isn't the ideal solution, however, mainly for 2 reasons. First, hoppers are pretty slow. Admittedly, this isn't as big of a problem as it may seem, because the hopper line will run at hopper speed, and the item filters below will also run at hopper speed, meaning that these guys are both in sync. There is no bottleneck. The hopper line is not the bottleneck here. The problem comes when you try and parallelize the sorting operations. If I have 2 item types in here that I want to sort, in this case diamonds and redstone, well, while the diamonds are sorting at the fastest possible speed, which is hopper speed, the redstone slice is not doing anything here. It has to wait for the diamonds to be fully sorted before the redstone has a chance to go through the hopper line and get sorted itself. So, it's better to use a water stream, transporting the items as entities. Using a water stream means that we can transport multiple item entity types and allow every slice to work in parallel to each other to their maximum potential. When using a water stream and dropper as your input system, you need to be careful and make sure that the hopper item filters and the dropper stay in sync, because unlike when you used hopper lines for your input, droppers and hoppers are not the same, so they can go out of sync. Since hoppers run on a cooldown of 8 game ticks, making sure that your dropper only spits out an item every 8 game ticks can be one way to ensure that your dropper and hopper item filters stay in sync. However, even when only inputting items every 8 game ticks with the dropper, the items and the hoppers can still go out of sync, causing items to not be picked up by the item filters. This happens because the dropper applies a little bit of random momentum to items that it spits out, meaning that some items arrive before the 8 game tick cooldown on the hoppers has passed. We can fix this simply by removing the random momentum that the dropper applies to its items. This particular design uses flowing water to align the items, making sure that the items travel consistently every time. Just because we have water streams doesn't mean we automatically achieve parallelization. Time to figure out parallel entity sorting. To achieve maximum efficiency in parallel, we want to send out items of different types at the same time while waiting before sending out items of the same type again. Let's say we inputted items into the sorting system like this: 2 batches of 63 diamonds and 1 batch of 63 redstone. There are a few ways we can input this into the sorting system. The most straightforward way is inputting all of these at hopper speed. Although this is pretty reliable, it comes with the drawback of being pretty slow. The redstone has to wait for the diamonds to finish sorting in order to start being sorted. This means that although the diamonds are being sorted at their maximum possible efficiency, the redstone slices are just doing nothing while it waits for the diamonds to be sorted. This is the same problem we have when using hopper lines, so there's really no point in using water streams if you're going to input items like this. You could also just have 3 droppers running at hopper speed and assign 1 batch to each dropper. However, since the diamonds are being unloaded at twice the speed that the diamond slice can handle, while the redstone will be sorted just fine, the diamonds are going to get overloaded, meaning the items are going to skip their item filters. No, the best way to input these would be to input 1 batch of diamonds and 1 batch of redstone at the same time at hopper speed, and once those 2 batches are finished inputting, input the second batch of diamonds. This would mean that the diamond slices would not be overloaded, and the redstone slice would be working alongside the diamonds, meaning it wouldn't take as long as just inputting them in order at hopper speed. But that's in theory. How would we go about doing this in practice? Well, we could have 2 droppers like this, running at hopper speed, and then input diamonds into one and redstone into one, basically making their own parallel input. This way, if we sort the items before inputting them into the system, we can take advantage of maximum parallel efficiency. We could have the player manually sort different items into different lines, but that wouldn't work. The whole point of the storage system is that the player can input mixed items and the system automatically sorts the items. If the player had to manually sort the items, well, what would be the point of that? Instead, we must sort different items into different parallel inputs automatically before sending them into the system. But wait, aren't we just sorting the items twice at that point? And if we're making another sorting system for the input, then we're going to need another sorting system for the input to that input, and so on. We're going to have to sort items forever. No, that would be ridiculous. Instead, so that we don't fall into an infinite loop of item sorting for parallel efficiency, we use a different method of item sorting for the input. Introducing variable item filters. First, think back to how the AP tileable signal strength independent item filters were configured. It had one of the item that you wanted to sort in the first slot, and 21 filter items in the other slots. When an item corresponding to the first slot enters the hopper, the comparator increases its signal strength, unlocking the hopper beneath, and allowing one item to pass through. Once that item passes through, the comparator decreases its signal strength once again, locking the hopper and not allowing any more items to go through. Variable filters act differently. Variable filters start out with the first slot empty, but have 22 filter items instead, meaning that even if one item fills the first slot, the comparator increases its signal strength enough to unlock the hopper beneath. But there is a bit of a delay, which means that the hopper below doesn't actually unlock until another one of that item comes through, assuming there's a steady flow of that item at hopper speed. The hopper below takes the second item out of the first slot, but before it can take the first item and break the filter, another of that item comes through, and the hopper has to take that one instead. This means that due to the constant flow of items, the hopper below can never take out the first item out of the first slot, even though the hopper is completely unlocked. Once the hopper stops receiving that item, the hopper below is able to take out the first item, leaving the hopper unassigned and ready to be assigned a different item. Let's take a look at how variable filters are used to parallelize our input. This is the set-based parallel unloader array by the Glade. I'm pretty sure I'm pronouncing that right. This is pretty much our ideal parallelized input. It works by taking shulker boxes as input and moving them around the machine. It might be a little overwhelming to try and understand this machine while looking at the components directly in the game, so I'll try and explain this using simple visual diagrams. When the unloader first receives a shulker box, it attempts to determine the leading item type of that shulker box. Hoppers take out items from containers in the order of left to right and top to bottom, so the leading item type is basically the first item that the hopper will take out of the container before all the others. The hopper takes that leading item out of the shulker box and puts it into a chest, where the set will be stored, hence the name set-based unloader array. Then, the shulker box is sent over to the unloaders, where variable filters are used to only take the leading item type out of the box. The leading item type is taken out first out of the shulker box to form the filter for the variable filter. Then, as the filter is formed, every instance of that leading item type is taken out of the shulker box. The really cool stuff happens when more boxes are inputted while a box is already unloading. The machine determines the leading item type of the box, like procedure, and compares it to the set. If the item is already in the set, that box is rejected and sent to buffer to be checked again later. If the item is not already in the set, that means that that item type is not being unloaded at the current moment, meaning that that box can be sent into the unloader array to be unloaded in parallel alongside the box that's already being unloaded, as they are different item types. And then, once the shulker no longer has any instances of that leading item type, therefore cutting off the constant flow of items, the variable filter unassigns and the shulker box is broken, to be sent back into the system in order to empty out the rest of its contents. Once all instances of an item have been unloaded from a shulker, the key to that item in the set is also unloaded and inputted into the system along with the rest of the unloaded contents. Now that all instances of a leading item type have been unloaded from the box, the next leading item type is completely different, and this leading item type is assigned to be unloaded, and so on and so forth until the box is completely empty and all its contents have been unloaded. The unloaded items are inputted into the water stream in batches of 20 or 40 depending on the type of item filters used, with the exact amount of time in between batches needed for the hopper to sort one batch. In practice, it looks something like this. You take mixed boxes, input them into the system. This is the set, the keys are being generated. This is a list of the items that are currently being unloaded. The shulkers are being unloaded right here. Notice how it only takes out the leading item type, and once this leading item type is fully unloaded, it breaks the box. Items are sent out like this. Different item types can be sent out at the same time, but multiple batches of the same item type cannot be sent out in order to not overload the filters. By the way, since one instance of the leading item type needs to be used to make a key, both the leading position in the shulker and the second leading position in the shulker need to be the same item. For boxes where the second leading item type is different from the leading item type, the machine detects that and takes out the single item and unloads it into the water stream, while it checks the second leading item type, which has now become the leading item type. In a nutshell, we're sorting items twice, but instead of having dedicated filters for every single item type, we have variable item filters that can assign and reassign themselves based on what items are currently being inputted, along with some logic to ensure that no more than one instance of an item type is being unloaded at any given moment. There's also a newer parallel unloader by Ethical, which does pretty much the exact same thing as Glade's unloader at the exact same speed, just in a more compact form factor. It's able to achieve this because it uses a relatively new concept called dueling hoppers in place of conventional variable filters. I'm not going to explain what that is. If you want to learn more, go check out the Storage Tech Discord. Set-based parallel unloading is not the only way to parallelize your storage system, and not even the fastest way. But for the complexity, it's doing pretty good, so it's become pretty much the meta for storage tech as of right now. This dueling hopper unloader array is probably what I'll use for my storage system. Ah yes, all this explanation was just convenient buildup for me to design my own storage system. When designing a storage system, you need to ask yourself, what do I need from a storage system? The first step to doing that is figuring out how the items will be organized and presented to the user. In conventional storage tech, there are three main methods of item storage: chest hauls, multi-item sorters, and bulk storages. First, let's explore the most familiar one, chest hauls. Chest hauls are for storing items that require medium capacity. They usually feature 8 or 10 item types per slice that can all be accessed by the player. Items are picked up by item filters from water streams and directly stored in double chests. Usually, chest halls allocate 1 to 2 double chests of capacity to each item type. This particular design by I Am Bob is made to be one wide AB tileable, allowing for the use of signal strength independent item filters. When considering chest halls and really any storage tech component in general, it's important to figure out which features that it has. For example, this chest hall features signal strength independent item filters for every item, and 100% hopper locking. Now you might be wondering, why is hopper locking important? Hoppers need to run a lot of operations, such as pulling items from and pushing items into containers, and also need to run a lot of checks, such as checking for item entities or containers above. They also need to do this a lot of times, pretty much every tick, which makes them really laggy for the game. But if we lock a hopper by pushing a redstone signal into it, then that prevents the hopper from running any of its checks or operations, making it way less laggy. In a fully fledged storage system with potentially thousands upon thousands of hoppers, the difference between locking them and not locking them can be astronomical. That's why we want to make sure that we can lock as many hoppers as possible in a component, so that we can have a circuit that locks the hoppers when the storage system is not processing items. Now, chest halls fulfill a particular need, but what if you want to store more of an item, such as items from farms that you'll have more than 2 double chests full of? That's where bulk storages come in. The core concept of a bulk storage is actually fairly simple. Instead of storing the items directly into chests, you instead first put the items into shulker boxes, break that shulker box, and place those into chests, allowing you to have far more items in a single double chest. There are many ways of executing this concept, but this bulk storage design by Parallelization represents a conventional bulk storage. It stores shulker boxes full of items in a chest, and displays the first shulker box in a box display for when the player needs less than a shulker box of an item. It also automatically replaces the box display when all of its items are taken out. It can also store up to 1.8 million of one type of item, storing the item in chests that are inaccessible. Up at the top, it features a box sorter to sort the boxes into their correct slices. Now, what is box sorting, you may ask? Box sorting is the method used to sort boxes full of a single type of item. A keygen takes one item out of that full shulker box in order to generate a key. The box and the item are put in parallel dropper lines and are sent on their way. Below the item dropper line are item filters designed to pull items before a dropper can push the item to the next dropper. Once an item is pulled to an item filter, we know the correct slice for this box, and the shulker is pulled out of the dropper line in that slice. This shulker gets placed and the item is put back inside the shulker. Then the shulker is broken and stored in the chest below. You might be wondering why we would ever want to use box sorting. Oftentimes, in high-efficiency farms, items are sorted and put into shulker boxes that are then stored into chests, instead of putting the items directly into the chests, as they need to store a lot of items. This results in you getting tons of boxes full of the same item. If we didn't have box sorting, we would need to unload these boxes and load them back into other boxes, which would take forever. Box sorting allows us to sort boxes full of one item type way faster. This way, we can have a dedicated input for boxes full of one item type, but still be able to process mixed items. With these box loaders and item filters, we can create boxes full of one item type for the box sorter to sort. About those many ways I mentioned earlier, this is another method of bulk storage, known as an accessible loader hall. Basically, it brings the box loaders down so that the player can access it. So if you have less than a shulker box of an item, you can still access it. This might seem good, but long story short, don't use this. Not only is it more difficult to hopper lock, it also provides less capacity and makes it impossible for you to integrate box sorting into a system like this. I mean, if you don't think you need box sorting, then maybe you should go for this, but trust me, you need box sorting. Think about all those massive farms with shulker loaders directly at them. You'll have so many full shulker boxes you'll want to sort quickly. If you don't know if you'll have enough of an item to fill a shulker box, it should be in the chest hall, not in bulk. Lastly, let's explore multi-item sorters. Think of items you'll never need 2 double chests of capacity for, such as all the copper variants. Making individual slices for all these items would be unnecessarily tedious. So multi-item sorting, or MIS for short, allows you to sort multiple item types per slice, using a chest as a set full of keys. kind of similar to the set-based unloader array you saw earlier. A lot of people like to include multi-item sorters as part of their storage systems, but personally, I don't really like to use them. First of all, the main purpose of multi-item sorters is to prevent you from potentially having super long chest hauls, but personally, I don't think that's a big problem. This is a design for a storage system made to sort every single item in 1.19. As you can see, the chest hauls aren't really all that long. It's pretty manageable. Second of all, you can't really parallelize multi-item sorting operations. This makes them pretty slow. Admittedly, this isn't that big of an issue since multi-item sorting is gonna be for items that you will rarely ever input into the system. But you never know, somebody could input a shulker box full of waxed cut copper stairs because they had leftovers from a big build. It just feels safer to have 2 double chests allocated to every single item type. But that's just me personally though. If you think that multi-item sorters will be a great addition to your storage system, then definitely go for it. Now that we figured out how we want to store different quantities of items, we need to figure out which items should go where and our item layouts. There are currently over 1,200 survival obtainable items in Minecraft as of 1.21, and the only proper way to assign them is to go through each item one by one and decide whether they should go to chest hauls, bulk storage, or MIS if you have one. Fortunately, the Minecraft Storage Tech Discord has a spreadsheet that lists every item currently in the game, and they even have spreadsheets for each version. If you duplicate this sheet, you can go over every single item with the game, and using the information presented in the sheet, such as what number the item stacks up to or if it's survival obtainable, you can use the drop-down on the right to assign it to either bulk, MIS, or chest haul, and they will show up in these tabs below. 1,000 items may seem like a lot, but when you're using the spreadsheet, it actually only takes a couple seconds to determine the placement for each item, so you can actually get done pretty quickly. It's just really tedious. When deciding whether to put an item into bulk or not, try to consider 2 attributes of that item. How much of this item will I be able to obtain? And how much of this item will I ever need? If you can't get a lot of that item, you won't ever be able to fill up the shulkers in bulk. Conversely, if you don't need a lot of that item, even if you are able to obtain tons and tons of that item, there's really no point in storing that much of that item. If it's an item you can get a lot of and need a lot of, then it should definitely go to bulk. If it's an item you won't be able to get a lot of and won't need a lot of, then it should go to chest hauls or MIS. If it's an item that you can get a lot of but won't need a lot of, or an item you won't be able to get a lot of, then you should think about it more before deciding. In 1.21, there's a new aspect that you also need to consider, the crafter block. It allows you to automatically craft items with redstone. For example, before the crafter was introduced, it made sense to store gold nuggets in bulk storage because you would get a lot of them from gold farms. And although gold ingots were what you would use a lot, you couldn't get a lot of it without the tedious effort of crafting the nuggets. But now, with the crafter block, you can automate the process of crafting the ingots, making it so that gold ingots fulfill both criteria. If all of this is sounding a little difficult for you, don't worry, you don't have to design your own storage system. If you go to the Storage Tech Discord, you can almost certainly find a pre-designed storage system that'll fit your needs. The only reason I'm designing my own storage system is because I like designing things to understand the process behind what I'm making. And because there aren't any storage systems out there that fit my needs, such as sorting every single item in Minecraft 1.21. Designing storage systems definitely isn't for everyone, so you don't have to feel pressured to do it. But if you're feeling up to it, it's time to move on to the next step. If you've decided which items should go to bulk and which items should go to chest hauls or MIS, it's now time to decide on the layout of your items. The way I do it is to visualize the layout in a spreadsheet first, and then make it in-game. Since I'm going to be using a chest haul design that has 8 chests per slice, I make 8 columns like this. And I'm going to have 2 chest haul wings, so I separate them with the line here. Each chest haul is going to be 60 blocks long in order to sort all the items that I needed to. I also use conditional formatting with a custom formula to highlight any items that are also in column A. Column A is the full list of the items that will go into the chest haul. So, if the item is highlighted, I know that it is also in column A. And column A also has this custom formula, so if everything in column A is highlighted, then I know that every item has a place in the layout. We all make mistakes, and you're bound to look over some things while making the layout, so it's best to have a computer double-check your work for you. It's time to actually configure the chest hauls in-game. Now, I know I've been showing off the chest haul by I am Bob this entire time, But the chest haul I'm actually going to go with is the one by Vipim, because I like its UI better. That flush floor is just immaculate. Since you probably know exactly how many slices for the chest haul you're going to need, all you need to do is tile these until you have the right amount, so that you can start to configure it. You can do this by moving the schematic in the direction you want to tile it and pasting it over and over again. Or you can try using World Edit if you're big brain, but I'm dumb, so I'm doing it with Lightmatica. Man, these chest hauls are long. Setting up the block displays and the item filters can be really time consuming. Fortunately, a Scarpet script exists that can do it all for you. First, you install the Storage Tech X script for Carpet by Command Leo. I'm too lazy to explain how to install it here, so I'll have links to the instructions in the description. Next, before you do anything, you need to create an item list. You can do that with the command /stx item list, create, name of the item list, and items. And then you can list your items with spaces in between. If you made your layouts in Google Sheets like I did, what you can do is copy the column you want to make an item list for, and then use a text splitter tool to put underscores in place of the spaces so that the names are in the correct format. And then run it again to get spaces in place of the new lines. And then you can now paste in the correctly formatted list of items. Since this is probably going to be a really long command, you should enable the carpet setting chat message length limit unlocked, or run this command in a command block. Once you enter the command, you're probably going to have to rename some items, as some items have different names from their identifiers. Once you create the item list, you can do a bunch of cool things with it, such as filling the filter hoppers auto-magically. Item list. It is filled automatically with its dummy items. The dummy items are configured in 17.1.1.1 instead of 18.1.1.1 to allow for one more filter item in the first slot. It's just better for security. The second filter item will automatically fill up and stay in once items start coming through. You can also automatically fill in the block displays. To do this, you must convert the item list into an item layout. First, place in your item list as item frames. You can do this with the command /stx item frame place, and then input your coordinates facing up. Item list, bottom right one. To mess around with item layouts, you need to get the STX module item layouts. You can do this with the command /stx modules, install, and item layout. And then you can use the command /item layout save, and then enter your coordinates and the direction which your item frames are sticking out of. And name it. And you have an item layout. After removing all the item frames, you can paste in your item layout. /item layout, paste, bottom right one, the direction you want your item layouts to go, and the direction you want your item frames to face. Oh, right, it goes from your current location. My bad. There you go. Pretty cool. You probably still need to touch up manually on a couple of things, like this dead coral needs water in order to stay alive, and this is probably seagrass, it needs a support block under it, etc. But the point is that it does the bulk of the work for you. Oh, my face was way too close that time. And now just set the item filters and the block displays for every single row and for every single chest haul. Okay, well done. That actually took like 2 days. What the hell? All the block displays are set. Very cool, very pretty. Yeah, it's actually a very cool experience to just fly through these or like run through these. Like, oh yeah, this is really pretty. And also all the item filters are set as well, all made possible by the Storage Tech X script. Now for the bulk. So we want to make this longer because we obviously have more items than this bulk can accommodate. So in order to extend this, we want to figure out which section is the part that we can actually elongate. You know, like the end cap versions, like the U-turn here and the box order here, they can't be part of that because they can't, you know, be elongated. So we want to take out this middle section purely and then make that longer and then cap it off with the U-turn and the box order. So I have 106 items that I want to sort in bulk. So I think I'm going to make this 60 blocks long since 2 items can be sorted for every slice. So that would be 60 slices for 120 items, just so that it's the same length as those chest hauls, and so I can add more items later to the bulk if I want to. I think I'm going to split them along starting from here and ending at right here, just so that the repeater locking lines match up when I try and tile them. So that means that there's going to be an extra 1, 2, 3, 4, 5, 6, 7, 8, 9 slices from the cap ends. So that means I need 51 slices in the middle that I need to elongate this middle section to. So this section that I've carved out from that over there is 12, 13, 14, 15. About 15 blocks long, right? Yep, 15 blocks long. So I need 51, so that's going to be roughly 3 of these and a little more. Paste the second one, paste the third one, and then I want it to be 51, so maybe I can paste another one and then shave off a couple of blocks. But let's just confirm that this is indeed 60 blocks long, because it should be. Indeed it is. So I need to shave off everything that isn't a part of those 51 blocks. Done. Oh, that sent some updates. Hopefully nothing too bad, nothing too catastrophic. Thank God I have liquid damage turned off with carpet mod. So now we need to add these 2 cap ends to that over there. All done. Gotta fix up a couple of things like this water stream for the overflow and the instant rail lines. With the setup for this one rail line I forgot to mention completed, all we have to do is paste the box loaders up at the top here, and our bulk storage will be ready for configuration. Oh wait, I need to update these things, what? So now that these box loaders are correctly pasted in, all we have to do is configure the water streams and the item filters and the box sorter filters, and our bulk will be ready to go. So now that we have both our chest halls and our bulk halls configured, we need to design everything else that isn't a hall, which will include things like your overflow, your unstackable sorter, your shulker storage, or maybe even a furnace array, your crafting station, your shulker box input, and your main input. And this will lead into your halls. Now that that's done, we need to place in our parallel unloader. I was thinking maybe we could place it here, but maybe the bottom would suffice better. Yeah, we have a bit of empty space here, so we might as well. This placement is a little close to everything else, but being compact is always a good thing, so hopefully it doesn't cause any issues. If it does, we can always just move it later. Now the next step is connecting up all the water streams. Our interface here has 2 outputs, main, which should go into the parallel unloader, and bulk, which should go to the box sorters up at the top here. Our streams are connected. Now to connect everything else. Everything is connected up. The main input goes to the parallel unloader, and the output from that first goes to the bulk box loaders up there, and then through all the chest halls, and once it's gone through all the chest halls, it'll go into the unsorted section. And unstackables will, of course, go to the unstackable sorter. Next, we want to figure out our shulker storage. We have 3 components that need a supply of fresh shulker boxes, such as the bulk input, which needs shulker boxes because they have box loaders, and as well as the interface, which needs shulker boxes in this chest supplied to function. I would also like all of my shulker boxes in the system to be gray, so we need a machine that can separate the gray shulker boxes from the other color shulker boxes. The shulker color sorter and storage solution by Kikugie, I hope I'm pronouncing that right, does exactly that. The way I've configured it is if this comparator detects that the shulker boxes for the bulk box loaders are running low, it sends a signal all the way down using these pistons and requests some boxes. But what also needs boxes are these overflow box loaders and the interface. So what I've done is created 2 pathways, one that leads to interface and box loaders combined, and one that leads to the bulk box loaders. And here is the path splitter. If it receives a signal, it knows that this signal is from there and that the bulk box loaders need boxes. So it pushes this piston, opening up this path, allowing items to go through here because of the momentum. And they will go to the bulk box loaders. However, If the signal is coming from these two things, this pathway here, then it knows that it's not the bulk box loaders that need boxes, but the interface and overflow box loaders. So it retracts this piston, closing up this path and allowing items to go here. I also have a comparator here to detect when the main box storage is running low and to send a signal down to unlock the hoppers down here and receive more shulkers from the shulker input. And yes, I know that this wiring is very scuffed and it's probably going to break a couple things down the line, but it works. It works. I tried so many hours to use this. Please, it works. Now we just need to take care of the hopper locking and the chunk loading. The bulk haul comes with a system already to lock the hoppers. So all we need to figure out is locking the hoppers in the chest halls. After making a circuit that can lock the hoppers when it's being unpowered and unlock it when it receives a signal from the back here, what you can do is use a comparator fader pulse extender. The reason we use fader pulse extenders is because they can be instantly reset. So basically, this pulse extender extends the signal it receives to 85 seconds. But every time it receives a signal, because an item comes through and activates this pressure plate, then it'll reset the amount it extends the pulse to back to 85 seconds. So basically, every time an item comes through, this pulse extender will output a signal for an additional 85 seconds after that, allowing the item to pass through and get processed. With this hopper locking, we can check how many of our hoppers are unlocked during idle. By selecting our storage system using World Edit, we can count the total number of hoppers present in the system. So there are 8,247 hoppers in the system. And out of those, the ones that are unlocked are 281, which is pretty good. That's like 4%, right? 96% of our hoppers are locked when the system is idle, which means that it won't lag a lot. All that's left to do now is to figure out our chunk loading system. But why chunk loading? Well, if you leave your storage system to run and then go really far away so that the storage system unloads from the game, well, then all the redstone components could break catastrophically. Plus, it's really convenient to have your storage system be able to sort through your items while you're doing something else somewhere else. Chunk loaders load a 3x3 area centered on the chunk they're currently in as entity processing chunks. So we want our entire storage system to be inside those 3x3 entity processing chunks. So I placed down these chunk loaders in a configuration so that the entire storage system would be within its entity processing chunks, connected them up with redstone, and I also needed a circuit that would load the storage system when it was in use, but unload it when it was idle so it wouldn't lag. So I have a comparator fader clock here as well. This lasts the entire length an item takes to get from outside, out of the parallel unloader, this pressure plate, all the way to the end, which is the overflow right here. Plus a bit extra just for the leeway. But this means that the chunk loading array will only activate once items start coming out of the parallel unloader. And I would have liked for the chunk loader array to activate as soon as items got, outputted out of the interface, this pressure plate right here. So what I did was have a second fader clock, but this one doesn't last as long as that one. It lasts about 53 seconds, which is about the time an item takes to get from this location, the main output, this pressure plate, and go through the parallel unloader, and then get to this position, this pressure plate right here. So as soon as an item came through in the interface, it will activate the chunk loading array, and then it will be activated until it gets to here, which it then will activate this fader clock, activating the chunk loader array further until, it's done and it goes through the entire system. And also, with this fader clock right here, it meant I could integrate the dedicated bulk output into the fader as well, with like a clever use of tripwire hooks, because if an item goes through here, which is the bulk stream, and the item has to fall through here, it will go through this string, which will activate this redstone and activate this fader clock as well. And 53 seconds is about the amount of time it takes for the item to go through the dedicated bulk streams, and then go through the box sorters and be sorted. I tested it with the very last item in the very last slice, the item in the very last slice, which is iron. And 53 seconds is about enough time for the iron to get sorted into its slice right here. With the use of copper bulbs, activating this note block with a right click triggers this observer and turns on this copper bulb. Comparator reads that signal, pauses the interface, and also pauses the unloader array. I've also added like a beacon display to show if the chunk loader array is active or inactive. White is for inactive and green is for active. The chunk loaders are configured to only turn off when nothing is being processed in the system. So the chunk loaders being on or off is basically all we need to know for whether or not it's safe to save and quit to title or shut down the server. Now that I've added a couple of signs to guide the player on how to use the system, it's time to do some extensive testing. First, you need to make a copy or backup of your world. In my copy of the world, I'm going to be conducting the testing using the Hermitcraft S8 item set, which can be found in the Storage Tech Discord server. Paste that in and connect it up to your input using hoppers. You also want to ensure that your storage has plenty of shulkers in supply. With the Carpet mod and the Carpet TIS Editions mod, you can log any items that despawn with this command. That way, you'll be able to see if your storage system reliably processes items without any of them despawning. And now let it begin. Once you see items coming through, you should probably speed it up using the tick command. So here's our first catastrophic point of failure. This system is in place to pause the interface once the buffer all fills up. But not only is the comparator not outputting anything, the signal doesn't even reach the pause because of this glass. Redstone signals can't travel down glass. So I fixed that issue with the comparators and also linked up the empty box output from the parallel unloader array and our bulk storage to the shulker color sorter so that the boxes could be recycled. And with that, our storage system really feels complete and we should be ready to run our final test. It's probably going to take a while, so I'm just going to run it in the background while I go do something else. So after running the tests again and fixing the issues that were revealed with it, I think this storage system is finally complete. I'll be leaving the world download in the description for anyone who wants to take a lightmatic of it and maybe build it and use it in their survival world or server. But the final question I want to ask is, was this all really worth it? I mean, like, look at this. It's so big. It's such a monstrous, gigantic machine. And, like, it took weeks, maybe even a month to design it. And not only that, you have to build this in survival to even use. And that will take even more, well, maybe not even more time, but, like, that would take so much time as well. So, like, why not just use the chest tracker mod?